All right, let me try to do the screen share and display the document that we'll be using for our discussion on the data structure called the stack. So the stack data structure. So I'm trying to load the document so we are able to use it for discussion this morning.
Sorry to disrupt this as the screen loads.
Yes.
I have a question.
Yes.
When we were introducing data structures, we wrote that data structures stroke data type.
Yes, data structure stroke data type. Yes, what's the question?
My question is, in the cut that we did last week, there was this question that was asking what is an array, and there were two choices. Is it an abstract data structure? Is it an abstract data type?
Yes, the array.
Yeah.
Yes, for the array, yes, that could have been quite confusing. Yes, I understand the issue there. Because in terms of the description of a data structure, I mean, the main thing is that we talk about the abstract data types, actually, abstract data structures. I mean, abstract data types. Now, that can be very confusing, I agree with you, because an array, unfortunately, is not a data type. An array is not a data type. And it's actually more of just a data structure rather than a data type. So I get your concern there. But what do you say about that, Wanjiko?
I don't know what to say. So we can simply say that we can't use the two terms
interchangeably.
Yeah.
Yes. I do sense your the confusion that may bring. And unfortunately, I don't know which would be the best way to go, because yes, an abstract data type is an abstract data structure. But when it comes to the array, there is that, and that is only the array. Unfortunately, it's the only one which seems to not to fit within that description of saying an abstract data type is an abstract data structure. So I don't know what would be the best way to go for that one, because it's only the array that misses that kind of a description. So it's like maybe we should normally put it with what we can say an exception, because but again, when you come to talk about the abstract data type, you are talking about a data type, and array is not a data type. So I think that is where the problem comes in, because we don't know which one you start with. You do start with which brings the other. I think that is where the concern is, which creates the other. And essentially, the data type creates the structure. So that's why it is sometimes generally put that way, that the abstract data type can be used interchangeably with abstract data structure.
Yes, thank you.
You're welcome. Well, you're welcome. All right. So we can go ahead. So Wanjiko, now that you are using your mic, could just let me know, is the document displaying on your end?
Yeah, it is.
Okay, thank you. So we'll go ahead and look at the data, the stack. So the stack data structure. So with the stack, again, just to remind us that for all these data structures, of course, there are a few that may not be very easy to locate in day-to-day life, but quite a number of these data structures uses names associated with some things that we either see or experience in day-to-day life. And I said sometimes that it is helpful if you can start by remembering how this word is used in day-to-day life. The word stack. The word stack. We usually we make use of this word meaning describing a group of items. A group of items. So a stack is like it's like a collective word. It's a collective word that describes a number of items that normally are stored, placed one above the other. Normally is what you can call a pile, or a pile. I don't know which other word that comes in there in a stack. So we do meet this word, the concept of a stack, like a stack of chairs, a stack of books, or anything else that you can be placed one over the other, kind of going upwards. We place the items one over the other and going upwards. Now that is the experience in day-to-day life of what we call a stack. And so we say a stack of chairs, a stack of plates, a stack of books. There are, of course, some items that are quite popular, popularly organized into a stack. Anything, of course, that can be arranged one on top of another one neatly. Of course, in a neat way, we are fond of arranging them into a stack. Of course, in most cases, for the sake of saving space. Anything that can be put that way helps us to save some space. And of course, it's obvious we don't always have all the space around us, and so sometimes you have to stack some things that is possible, and we create what we can call a stack of something. We put what we can call a pile, and that way. So this word, the stack, is actually borrowed from a similar concept. The way it is used in computer science, it's based on a similar concept. And so a stack, therefore, now looking at the text there, says that a stack is a linear data structure which follows a particular order in which the operations are performed. Now, going back now to utilizing this concept now in computer science, we're saying is a linear data structure which follows a particular order in which the operations are performed, and the order may be described as LIFO. That's a mean word. We normally look at the stack as a LIFO, last in, first out, last in, first out, or FILO, first in, last out. But in most cases, we prefer the first one, the LIFO. So it's a LIFO data structure. But something else to note is that it's linear. So stack is linear, and we did discuss the properties of identifying a linear structure. So it means that it obeys those properties of a linear structure. And then, of course, again, now, of course, when we now look at it from the computer science, we may not always look at it as something that is moving upwards, of course, but we should start there and then build on it. So when we get to now the main operations which are performed on the stack, actually there are two of here it's talking of three, but let me first of all emphasize on the first two. These are the most popular operations in a stack: the push operation and the pop operation. The push operation is for inserting items into a stack. So when you add something onto a stack, when it comes to operations now in the computer, we call that process push. Then there is a pop. So for the pop is when you remove an item from the stack. So when you remove an item from the stack, that operation, we call it the pop operation. So these are very popular operations that are done when we are working with a stack. But of course, there are a few other operations, as you can see here. In fact, it's talking of three, but the text here has actually four, and there could be maybe one or two more that are not here. But okay, there are these two others, the peak and the is empty. So the peak, as it says here, returns top element of stack. In other words, if you are writing a kind of a program, then one of those one of the functions that you will add to your program is either the operation or of course a function called peak, or the operation called top. Of course, they may not bear these names because these words may not be usable in every programming language. But of course, you can see these words. But again, you cannot use your own. But know that this word or what this operation is to give you to let you know. It's like saying now what is the item at the top of the stack. We'll talk about the word top in a short while. Then, of course, there is one which is called is empty. Is empty. So this as it says, returns true if stack is empty. If stack is empty, then it returns true. So this particular function or operation, it returns true. In other words, it is confirming that the stack is empty. There is nothing in the stack. Of course, if there is something and you have used this operation, then it should return false. All right. So we have. So of course, as we said, we start by looking at the ordinary usage of the word, and then now we move now to computer science, to programming, and we utilize that knowledge in creating a program. All right, so the stack data structure. Now there is a diagram here, but as you can see, it's actually not really showing the stack the way we know it. Notice that the items here are not seem to be placed one above the other. It is now looking horizontally. It is like items placed on the ground, one next to each other on the ground, but of course together there. So of course, when it comes now to computer science, there is that we have of course to know that we are only adopting the word, but we are not. It cannot be used exactly that way in a computer system. But once in a while, we do try to draw this diagram in a different way so that it looks more of a stack. And I think, okay, yes, I think we'll go to the whiteboard and do a few activities there, and then we can come back to the text so that we can fully follow the concept of the stack. So I'm going to remove this document here, then we will go to, let me see. Yes, we'll need to remove that. So let me unshare that, and then we come back to that document. So let's try to just understand the concept of the stack first by using the whiteboard. So in the ordinary life, if you had to work exactly as the ordinary life stack works, then we can use now one of the ways of implementing a stack, of course, is to use an array. See, if you use an array, then you fill in items into the array, but treat the array as a stack. You make sure that your program, while it is creating an array, but will treat the array as a stack. So, but let's try to just be follow the usual concept of a stack. You see, if you were to follow the usual concept of a stack, you would draw something like this, a box, of course, with the divisions, and assume that then we subdivide this box into divisions like that, and each division represents an item. So let's say we are creating a stack of books. Although we have started by having the space, but assume we want to have a stack of books. So we're saying e.g. Sorry, I think my letters are still too big. Let me reduce them so that we are able to use the space better. Sorry, I think I needed to activate my text tool. All right, so if we are thinking of a stack of books, all right, so we're trying to assume that we are just looking, of course, that we are just trying to come out of now the ordinary experience of stacks. And we say that now these are the space. So this is just describing a space where we have the space that we can create a stack, but it's going to be a stack of books. So when we add our first book, normally we put it, of course, it will go to the very bottom. So when you put our first book, you go to the bottom. So down there, we'll have our first book. Now we are going to still do both. We combine ordinary life and also the concept of the array. So assuming that this is all these spaces for an array is like a space in the array, of course, without right now showing all the spaces. And so when we put our first book here at the bottom here, then we continue to add some more books. So we have our first book somewhere here, and then so maybe that one we'll call it our position 0. Of course, as we said, we have to combine both the ordinary stacks and also bring it closer to our understanding of how it will going to be done in the computer. So that is position 0. Now, when we add when in a stack, there is always the item at the top. In a stack, there is always the item at the top. And so this is our first item, and it is also the one which is at the top. As far as the items that we have put in the stack are concerned, that first item there is the item at the top. Now, when you want to add some more items, you keep adding them at the top. And remember the word we saw in the document called top. So we'll revisit it and see again how we are starting to talk about that word, top. So top is the place where the top item is. So when we put our next item there, which now array, borrowing from the array concept, that now is position 1. All right, the indexes. So remember the indexes. So the indexes of an array. So that is now our position index 1. But in terms of the stack, it is now the item at the top. So you notice therefore that the item at the top keeps changing as you add items. So earlier on, position 0 was the top. But when I add another item, then now the item at the top is no longer the one at 0. It is now the one at 1. Now when we keep adding, so let's add another one. You add another item into the stack, and array borrowing from the array, this will be a position index 2. And so as you add items into the stack, the item at the top, or whatever you can call the top, keeps on changing as you add more and more items. Now remember, we have already said that when you are adding items into the stack, that is the operation called push. So when you do push, you are adding items into the stack. So what we are doing right now is to do repeated push. As we do push and push and push, we continue changing the item at the top. Now there are two things that we must therefore capture here. One is that the item, there is a place called at the top in a stack, and that is where you add new items to the stack. New items into a stack are always added at the place called top. And then the operation for adding items at the top is called push. So items are always added at the top. Now, if we want to start removing these items, if you want to remove, no, before I go to that, now the other thing that we must capture is that the new item added to a stack always occupies the position one place above the previous top. The new item added to a stack always occupies a place which is one position above the previous top. So if you add a new item, now our top item right now, it is at the position called index 2. Now, if you add a new item, which now will become our new top, it will go to the one position above the current top. So if you add a new item there, which I'm going to try to do that, I add a new item here, it will now come to the position whose index, if you are borrowing from the array, that will be position index 3. So when you add a new item into the stack, the position of top changes. So the position called top always points at the position of the top item. There is a position called top. The position called top points at the position that is occupied by the top item. As you continue to add items into the stack, the position called top keeps on changing. So the top is not one position. The top is defined by the item at the top. The item at the top, that position is the one which is called top. And therefore, whenever you keep adding, whenever you add a new item, the position called top changes by 1. It's an increment. It is an increment of 1. Now, and so we can say when you add items, so when you insert, items, so adding items to stack. So top increases by 1. In other words, we can say top now, top equals top, and I'm sure you know that, this expression that I'm just about to put here. Unfortunately, this is not a mathematics software, so it cannot do the whole expression that I want to put here. I want to put the addition symbol there. So top equals top plus 1. Every time you add an item, top equals top plus 1. In other words, the new top equals the previous top plus 1. What about when you remove now? This now brings us to the other if you remove items from the stack, we say we call that operation pop, P-O-P. Now, when you remove items from the stack, so for example, suppose we try to remove the items here. Now, in ordinary life, if you have a stack of chairs, normally you start removing the item at the very top. So when you that's the ordinary way of doing it. If you wanted to do it, of course, what you can call carefully and ordinary, of course, the one by one, you start by removing the item at the top. Now, what does that mean? Now, the item that you put the last time, the item that was added last becomes the first one to be removed. And that's why we are saying last in. The last item that you added last in is going to be the first out. So last in, first out. So the stack, we say, is a last in, first out data structure, which in short we say LIFO. L-I-F-O. So if this is a stack, of course now we are borrowing from ordinary life, we start by removing the one at index 3 here. Okay, we start by removing this one. Unfortunately, that's going to be quite tricky, but I can try this. So we remove the first one. The very top item, it will be the first one to be removed, which I'm trying now to do. And this operation here is not agreeing to do that operation. Okay, it's because I had done some other things. I'll try to use this to remove my top. So you remove my top, yes. So I've removed my top. So now I'm now removing items from the stack, and you start with the one at the top. So when you do a pop, the item at the top is the one which is removed first. And then you continue like that. You can continue to removing and removing and removing. But again, now when you start removing items, again, there will always be the item at the top. So once you remove one item from the top, then after that, now you look at your stack again, there is going to still be something at the top. So the concept of the top in this case is that whenever you remove items from the stack, then the item, the position called top continues to be decreased by 1. So top, when you remove, top is decreased by 1. So if you are removing, if you are doing the, if you are doing the removing operation, so removing items from the stack, if you are removing items from the stack, then top, sorry, I think I touched the wrong thing. So top, top will be, or the new top, the new top will be equals to top minus 1. So this is a minus, sorry. It will be top. So the new top becomes top minus 1. That means, now of course, as I said, we are now trying to utilize both the real life as well as and combine it with the programming concepts. And of course, here we are borrowing from the array. And that if you remove items from the top, then the new top equals top minus 1. As far as, of course, is, as I said, we are borrowing from the array concepts. So these numbers indicate indexes as are used in an array. Now, so the top, so this is the pop. This is the pop operation is such that when you now consider the top, the position of the top, or the item at the top, will now be occupying the position top minus 1. And so, of course, you can continue removing your items from the stack until, of course, the stack is empty. And let's consider that situation. What will happen after you have removed all the items from the stack, which I'm now trying to do that. So I'm trying. All right. Notice that we still have one item at the stack. Now we're asking ourselves if and of course that is when the stack is empty. Right now, the stack is empty again. But since it is still a stack, it's an empty stack, we still have to ask ourselves now, where is the position? What is the index of the position of the place called top? Because if it is a stack, even if it is empty, you still have to think about those concepts. So where is the position called top? I think one of the quicker way to try and think about that is, suppose we first of all put back our first element here, which was at index 0. We first of all put it back. We put, so this is at index 0. So we need to use a different tool. So when the stack has one item, that item will be occupying index 0. Okay, it will be occupying index 0. And we have said that when we are removing items, so sometimes good to learn backwards from what we know and try to get what we may not know. So we're saying if you remove items from the stack, the position called top this is equals to top minus 1. Okay, the position called top will become top equals top minus, or it will be top minus 1. Now, when we have just one item remaining in the stack, that item occupies the position index 0. So if you consider the array as our implementation structure, so when we remove this item, then what will be the index? Now remember, if you remove this item, then the stack will become empty. If you remove the last item, then the stack will become empty. Then what will be the index of the top, the place called top? What will be the index of the top when the stack is empty? When the stack is empty. So I would like us to do some interaction there. All right. Let's do some interaction, and I want you to say what is the position of the top when the stack is empty. What is the index? All right. What is the index of top? Let me say of top when the stack is empty. Okay, because we're saying now, let's start by starting to remove items. Remove items. Now we have just one item remaining. It is at index 0. So when we remove that one, what would be the index of the top? So let's see your correspondence. I hope you are, of course, every gadget can write some numbers. So let's interact at the chart. And I want you to write there what will be the position of, or what will be the index of top. Top means the item at the top. So that place where the item at the very top of the stack. In this case, if the stack is empty, what would you say about the index of the place called top when the stack is empty? And that is, of course, used to test if the stack is empty. Yes, so I would like you to write there at the chart what would be your value for the index when of the place called top when the stack is empty. So let me have every one of you should write something there. Write your value and post it at the chart area. So quickly there, let me see your values for the stack. What would you put as your value for the place called top when the stack is empty? Yes, let me have more. I can see Wanjiko has put a value there. Yes, I can see a number of values there. Who has not put? I think I should be having one more. From who? Okay. Who's missing there? Cleophas. Where is your value? All right, we have a -1 repeated. There is a 0. So which is which? All right. Cleophas has a value, another value called null. Okay, so so which is which? Which is which? So when the stack is empty, when the stack is empty, where should be the place called top? Now remember here, now we are now trying to think in terms of an array. So if it's a we are using the mind of the array now to deal with this situation. And of course, it is very true that the array can be used to implement a stack. But then, of course, it will behave as a stack in that case, because we will limit the operations possible and make sure that there's operations that are possible are only those that operate as a stack. Well, in this case, thank you for your values. In this case, we'll just follow the mathematics. Okay, if you follow the mathematics, then you find that from 0, if you reduce this by 1, it will become -1. And so the correct value here is actually -1. So when the stack is empty, okay, when the stack is empty, because here now you can see there is something in the stack, and that it is only one item, but that item, it is the only item, and therefore it is there. It is the one at the top. At this moment, it is the one at the top. So when we remove it, then we reduce the index of the top by 1. So in other words, you just get 0 minus 1. And so when if we are writing a program, so to test whether the stack is empty, is to say if top, and remember your program must be doing some calculations automatically. Keep on if we have a stack and or of course a program for the stack, it must keep on evaluating where the top is. So there should be a line over in the program that says where the top is all the time. And so when we move this item, it should have calculated and put the value of the top as 0 minus 1. So when we test when we test that the program and find out where is the top, if we find that the value of top is -1, automatically it tells us that the stack is empty. So we test for the emptiness by asking the the program whether the value of stack is -1, and then we say else. So you say if a top equals -1, return true, else return false. Actually, you don't really say -1 normally. Normally you say less than 1, less than 0. If top is less than 0, then return true for emptiness. So this is a stack, and that's how it operates. So there is a place called top, and the place called top is the position occupied by the top element in the stack, whatever that element is. Of course, remember now we are borrowing two concepts. We are borrowing the concept of an array, and we are also borrowing the concept of an ordinary stack. But remember, in programming, of course, you cannot talk of something at the top in terms of, physically, there is nothing physically you can see as top in the programming. When you create the program and you organize your data, there will not really be anything that looks like something arranged moving upwards. But we are borrowing those concepts, the concept of an ordinary stack, and it gives us the concept of the word top. But that word top, we now use it in programming. Now let's go back now. We go to the array and we talk about the concept of the array now. We say, the indexes. But again, that is it's only useful if we assume that we are using the array to create our stack. But many times we don't use the array to build our stack. We can use also the linked list again, in which case the concept of the index may not always be very correct. But of course, is a starting point in learning about the stack. And so, in terms of applications, so let me go back to the document. I'm going to share the document again, so we can just look at a few more issues that are discussed in the document, just to make sure that we have looked at the various issues that need to be considered. Sorry, yes, it is trying to share the document. So let's start the document again. And there it is. All right, so the document is showing there. So I think this one is quite way down. Let's go back. And actually, the stack does not have a lot of issues. Just you can notice that the document we have is quite short. Now, so we have only two main operations. The one which the place called top. This of course is trying to show a description of a stack, but notice that it is not moving from bottom to top, because of course that's only for analogy's sake. All right, so the place called top is the item at the very top. Of course, it means that we are adding from this end. So put push is to add items, pop is to remove items. And we have already said that the four main operations that happen, of course, the most important operations is push and pop, but there are also these operations that may be necessary once in a while. Do a pick is to say what is the value of the item at the top. So maybe again, this may be the index rather than the actual item or the position. You give what is the position of the item at the top. And so, of course, that can also be used actually to also check. No, sorry, this one actually returns the actual item. So is a 2, is a 3. then it will say there is the item at the top is a 3 or is a 2 or something. Then this one is to test whether the stack is empty. All right. Then we have just a few more issues is applications. So how does, well, of course, this is what we have been saying practically. And I remember again, we said the stack is a last in, first out structure. So the last item to be added will be the first one to be removed. Of course, there is other issues, time complexities of operations, and it says that all of them they take 0.1 time. And I will come to these issues of complexity when we'll be doing the analysis of algorithms. So I think we not overemphasize things there. What about the applications? Again, we can look at applications from daily, day-to-day life situations, as well as in computer science. In day-to-day life situations, we talk about a stack of chairs, a stack of plates, and a stack of what else do we do? A stack of books. There are quite a number of cases where we organize items into a stack in daily life. But when it comes to computer science, there are quite a number of applications we can talk about. So there are these ones which are listed here. Balancing of symbols, the concept of infix to postfix or prefix conversion, redo and undo features. In most programs, there is that redo, undo, and I think that one is even in this program that I'm using to display. If I delete this item, which I'm going to try and do, delete an item there, then you find that this item, this button is activated. It's the undo button. And of course, the undo button will reverse. It will reverse what I have just done. So what I did is to delete. So if I undo that, then the item will be brought back. Now, if I delete also another one, as I'm going to do, then I'll have done delete operation twice. And what this is saying is that this, when we do these operations, when I'm doing certain operations, the system keeps putting them into a stack. So it has a kind of a stack that it is creating to remember the operations that I have done so far. And it can, especially if I want to reverse it, so it can help me when I want to reverse it. Okay, I'm going to delete another word here. I delete this one as well. So I've deleted the items 3 times, and every time I'm deleting, these items I'm deleting, they are put into a stack, so that when I want to reverse the operations that I've done, first of all, the operation is also put in the stack, as well as whatever it was, whatever it did, the actual work it did. So, for example, I've done delete 3 times, but even what I deleted is also put into a stack, so that the last item that I deleted is one which is going to be placed back first. So remember, last in, last out. So the words that I was deleting, in this case of course, 3 different words. So the one which was last to be deleted is being put into a kind of a stack by the system. So if I do the undo, so this undo, they always operate within a stack. The undo and also the redo, or those they always operate in a stack way. So if I click the undo, the last one which I deleted will be brought first. Okay, so you see the ETC here is the one which I deleted last. So if I click undo again, then the next one, which which we can say the second last from the last, and of course the third one editors. So that's what it is saying here. Also that so a redo undo features actually operate using a stack operation, and all these, of course, all these are examples of situations where the stack or some kind of an operation behaves in a stack approach. So I'm not going to look at all these implementation. So the implementation, we said, how can you create a stack in programming? How can you create a stack? And you can create a stack in two ways. Of course, you can use an array. Of course, the array has its own limitations. And of course, is what we have been using for demonstration. But we can also use a linked list. Remember, a stack, we said, is a linear data structure. And of course, therefore, you can use the array, or you also can use a linked list. And so there are more applications of stack explained here. Maybe the one which, so read on this and try to understand and get some more materials to just help you to understand. It's quite a long discussion here. I think the two that I could just highlight again, these are quite easy to follow, is the concept. I don't think it is here, but there is a word. I saw the word palindromes, so you can find there is something called palindrome to test whether you have a palindrome. Palindrome is a word that is spelled the same. Whether you start looking at it from the left, we normally look at spelling left to right. When you are writing a word, how it is spelled from left to right. And when you try to spell it or to read the word letter by letter from left, from right to left, it is spells the same way. So that is, what the concept we call palindrome. I don't know why. I think I saw the word here, but I can't trace it very fast. So palindrome. So let me just make sure that we are following. So I'm talking about something called palindrome. Palindrome or palindromes. So these are words that spell the same, whether you look at it from left to right or right to left, they spell the same. So again, this I think would be a good point of interaction. So I would like you to write me some palindromes. For example, I think the easiest that I can remember is maybe madam. If you look at the word madam, you find that the spelling is the same whether you read it from left to right or right to left. So which means that the word madam is a palindrome. So I would like you to try and come up with a few more examples. So let's interact a bit. Yes, I can see. Yes, 2020. Is that correct, Wanjiko? Check again. When you start reading your values there, that may not be a palindrome. But yes, Cleopas, that's correct. Because it is still going to be E over E, whether you read it from left to right or right to left. So check again, try a different value, Wanjiko. Notice that if you start your word from left, it starts with a 2. But when you start from right, it starts with a 0. So which means it really not be yes, 11. But now I want words. Try words, because this is actually used with words rather than with numbers. It's about words. We say it's a word which spells the same way, whether you start looking at it from left to right or from right to left. There should be quite a number. Yes, there is somebody there who has had, yes, Wanjiko has come up with a level that is very correct. If you spell it both ways, it will still be level. Yes, that's a palindrome. Yes, another one. Notice that the word mama is not a palindrome because from left it starts with a name, from right it starts with an A. And Dixon has added the race car. Yes, that is very correct, but except that that's not that word, unless you not talk of it of two words. Do you have a word like that one? Those are two words, so it may not qualify because it's not a single word. Race car. But of course, if you look at it, both words together, yes, it will actually do. But again, there will be a problem because your two words will not. Yes, radar, correct. Yes, that one is very clear. It's a palindrome. Yes, so that's so when you want to test if a word is a palindrome or if you have some palindromes, we can use a stack, because what you do is to push your items into the stack. You see, and then you reverse. You see what you do when you remove items from the stack, then you are reversing the way you put them in. So so if the way you put them in is the same way they come out, then it will be, so we can use a stack to test for palindromes. Now the other one, which is again quite obvious to, or is easy to look through, is conversion of decimal numbers to binary numbers. So decimal numbers convert the decimal numbers, decimals to binary. So this is an operation that also can be done using a stack. So, and of course, the stack is needed to store, and then you do whatever you want to do with what you have stored in the system. Unfortunately, I may not be able to do this very well because of the system that I have with me. But let's try. Now, when you are converting decimals to binary, what you do is to do what we call repeated divisions by 2. Repeated divisions by 2. Now, let me just attempt. So if you have some numbers here, so let's say we want to convert, let's say I'll do a simple number that we can divide quite fast, like let's say 20. If you want to convert 20 to binary. The ordinary way of converting that to binary will be to do what is called repeated division. So you get 20 and you divide by 2. Now our interest here will actually be, and now because of time and not really wanting to take too long, let's just use a slash instead of the division, a symbol. We use a slash and say divide by 2. So you do repeated divisions, but here the interest is to get the remainders. The remainders are our interest. So when you do 20 divided by 2, it will be 10 remainder 0. Okay. So the check at now what is supposed to be done is that as you do the divisions, put your remainder into the stack. All right. So let's assume that our stack is somewhere here. So so somewhere here we have our stack. And as we get our as we get our remainders, we put them into the stack. So right now, put 0 into the stack. Then we do the next division. Sorry, so now here I'm going to try. Now let me put my stack retro up here so it does not get. So let me first of all put my space up. And then I'm going to put the stack retro up so that it is not taken down as I continue to do the division. So this is our stack that we are putting our values as we do the divisions, and we obtain our values for the remainders. We are putting them into the stack. So far, we have put a 0. Then the number, we talk about the quotient. The quotient is what you get after a division. So the number which is the result of because what you get is a value and a remainder. So these 10 now we divide these 10. So that's what we are calling repeated divisions. So now get the 10 and divide by 2. And of course, the result will be 5 remainder 0. Now our interest is the remainders. Now put your next remainder into the stack. Okay, now divide 5 by 2. And you get 2 remainder 1. Put the remainder into the stack. Now remember, since this is a stack, we're talking about put. Now this is what we are calling push. Okay, keep pushing you are pushing items. And remember, this was the first one. So this, if we are to have a proper concept of the stack, this would be at the bottom, right? So the one which we started with would be at the bottom. And then again, as we keep on adding items to the stack, notice the one which you have added the last is always the one which is at the top. All right. So now we have 1 at the top. Then we have again division. Now our value is these 2 is the one which we are going to do the division, and this one gives us so 2 divided by 2 is 0. No, it's 1. Sorry, is 1. Remember, our interest is the remainders. Is a remainder 0. So put a 0 in the stack. So this now becomes the one which is at the top. And then finally, now we always divide until the quotient is 0. So do another, although now, of course, 1 divided by 2 normally doesn't seem to make sense. But in this case, it makes sense in the operation of converting a decimal number to binary. So we do 1 divided by 2. 1 divided by 2. Now, how we write that is that it is 0 remainder 1. Remainder what? Yeah, remainder 1. So it will be 0. Sorry, 0 remainder 1. And so we put now 1 into the stack. Then what we do now to get since we have reached the end, when your quotient becomes 0, then it is the end of the operations. Then from now, we can now get our conversion. So the conversion, remember, we have been pushing this into a stack. And so this one is now at the top. Now remember, the stack is LIFO. So last in, first out. After doing the push, so push 0, push, 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 push. Now we are, the top item in our stack is 1. Now we start doing pop. So we do now the pop operation. Pop operation removes items from the stack 1 by 1, and it always removes the item at the top. So if you now do the pop, so what will be our values? What will be the order in which our values will be when we do the pop. Okay, so so we are doing a pop operation now. So when we do the pop, we start with the last one there. So of course you can see how to be. So starting from the last number, the order will be 1, 0, 1, 0, 0. And now that will be the converted value for 20 into binary. So we can use a stack to do the conversions. It does it very perfectly. And now, of course, the operation is just an ordinary mathematics. The issue is, if you are doing this in the computer, so the best way is create a stack. As you get your remainders, store them into the stack, keep pushing, do the push, push, push. And then once you have the quotient is 0, now do pop, pop, pop. And the values as they are being popped out, they will now give you the binary form of your decimal number. And so one of the applications of the stack in computer science or in programming, it can be used to do the conversions of decimal numbers to their binary formats. I think for today I will not extend beyond that. I will finish a bit early today, just to try and get some more things going. But is there a question? Maybe there is something that. So okay, let me remove the share. I don't think unless there is a question on this one immediately on this one. So let me first of all get to know, is there a question on what I have done right now, explaining how the stack can be used to convert decimal numbers to binary format? Yes, so I'm waiting if there is a question related to the demonstration that Mwalimu has just done. I would like to know if there is a question related to that before I remove it from the share. But you can ask any other question even right now. I don't think there is any reason why we cannot still communicate even when the document is still displaying. So you can ask any question related to our discussion. Then we can answer, or you can also make a comment on how you are finding this particular topic on stack or any other in the data structure that we have discussed so far. Yes, any comment, any question?
Yes, I have a question.
Yes.
Would it still be applicable when we are converting decimal numbers to octal? Because we also continuously divide by 8, and I think it's the same as binary conversion. It's only that this time around we are continuously dividing by 8.
Yes, there will be a challenge there, because when it comes to you cannot get it directly. All right, you'll not be able to get your values directly when you are doing conversions octal. So there will be a challenge there when you're converting to octal, because the octal has its own the way it represents its values is slightly different from the way you represent your values in decimal numbers, because the decimal are not decimal, but with binary. Because with binary, we have only two values. So we have only two values, the 0 and 1. and that's why it becomes easier. So for Octo, you'll be forced to, in this case, to just convert from its binary format. But when you are doing it, of course, it's the same concept. We use the same process, but it may not be possible to use the stack in that case. Yes, any other question? All right. If there is no question or comment, I think, so as I said, we'll end there. That will be the end of Mwalimu's presentation for today. I'm sure, of course, you must also be having some other issues that are pressing as far as the studies is concerned, because, as I said, of course, we're doing a lot of things together because of moving to this online communication approach. And so we are handling many things at the same time. But before you leave you do the logout check, there is a forum discussion, just very, very straightforward discussion there. The area of this is actually topic 3, is our topic 3. The start, so there is a place for topic 3 at the portal. Look there and access the forum for discussion, and it is mainly related to applications of the stack. The applications of the stack data structure in daily life, as well as in programming or in computer science. So for now, that will be all that I have for today. So I will want to allow you to attend to that forum, as well as to other duties related to your studies for this day. So from me, I say goodbye and have a great afternoon ahead.